And so, to begin with, I thought I'd provide a sort of um, a, hypotheses around this works. So, investigations or studies involving organ transplantation and psychology in context of psychological stress have retrospectively been quite rare, or are rare, and it is sort of postulated or hypothesized that psychological stress or stress is of importance within sort of those populations, in context of in context of the in and around specialties surrounding organ transplantation, and within the pre-transplant phase, and that stress can have an impact on organ prognosis, post transplant. And the hypothesis around this works, in the original works from 2006, have been to highlight have been where wherein or was that a reduction in stress in or psychological stress in particular in recipients pre-transplant versus patients who are stressed, improves transplant prognosis, or improves prognosis. And reduced psychological stress ultimately improves prognosis, but also reduces chemokine migration or trafficking into transplanted organ, as well. So, so in context of the background around this work, in and around this work, cytokines are small molecules that signal between cells, introducing differentiation, chemotaxis, activation, enhanced cytotoxicity, and or regulation of immunity. Chemokines are cytokines which direct cell migration and or activate cells, and interferons which are involved in defense against viral infection, and in activation and through activation and modulation surrounding immunity. Chemokines, closely related to cytokines, are produced by many cell types in response to infection or physical damage. They activate and direct effector cells to sites of tissue damage, and regulate leukocyte migration or trafficking into tissues. And the CC chemokines, or those that are referred to as sort of chemotactic or CC chemokines, are chemotactic for monocytes, as and CXC chemokines are chemotactic for polymorphonuclear neutrophils, or PMNs. And chemokine receptors are expressed on particular cell populations, permitting different chemokines to have selective activity. In the original works, there is a schematic that had been adapted as part of Rossi and Zlotnick's works in 2000, in which highlight or summarize works in regards to the functions surrounding chemokines. So, for example, where chemokines are important in the development, in the surrounding development of T helper cells type 1, T helper cell type 2, and angiogenesis and angiostasis, metastases, cell recruitment, inflammation, lymphoid organ development, lymphoid trafficking, and wound healing. And again, in Rossi and Zlotnik's work in 2000, where they highlight the works, highlight an overview in their works surrounding biology of chemokines and receptors, surrounding biological functions of chemokines and chemokine receptors. And continuing the sort of background aspects surrounding this original works, chemokines are primarily involved in attraction of leukocytes, lymphocytes, monocytes, and neutrophils in that context. And to attain long-term transplant prognosis or survival, post-transplantation has been an ultimate challenge for a variety of organ transplant specialties. Immunosuppressants, so for example, cyclosporin A or CSA, originally developed from the pharmaceutics organization for pharmaceutics known as Novartis. Cyclosporin A or CSA was originally developed from the pharmaceutics industry. The pharmaceutics organization known as Sandoz. The generic name for cyclosporin A or CSA was either Sandimmune or Sandimmune or cyclosporin, and then tacrolimus was developed from the pharmaceutics organization known as Fujisawa originally, and the generic name, the brand name was known to be Prograf, and was also known to be referred to as FK506 in context of its immunological the immunological premise of this particular immunosuppressant, and wherein either of these immunosuppressants have an impact in context of their potency in relating to cytotoxic CD8 T cells. This increase brings on the increase in the potency, if not titered appropriately, can increase and bring on acute allograft rejection episodes in transplanted recipients. And it is evident that these molecules or these particular immunosuppressants, for example, have potency and are potent agents for activating and directing effector cell populations to the site of damage, as well as for controlling leukocyte migration into tissues. In the original works, there's also a schematic or an overview surrounding chemokines and receptors in context of work by Cassieri and Springer from 2000, where they quite neatly in their works in 2000 have listed in a schematic the different types of chemokines and chemokine receptors, and in context of how those chemokine receptors chemokines and chemokine receptors are linked to particular ligands in context of physiological processes. And so the chemokines and chemokine receptor family in context of the schematic provides an overview in regards to chemokine receptors, whose ligands have been identified in context of processes aligned to immunology and other specialisms around different areas of immunology and laboratory medicine as well. So the chemo in the schematic in this works by Casari and Springer in 2000. They highlight the ligands alongside the receptors and how they are identified within the schematic, and how the chemokine ligands are also specific in context of the particular how particular receptors are linked to particular ligands accordingly. So monoclonal antibodies have advanced as well from procedures involving fusion of immortal cells, for example, myeloma tumor cells, with a predetermined antibody producing B cell. Most monoclonal antibodies have been through mouse mouse models, and initially monoclonal antibodies do not make at least in some contexts in around 2006 and before 2006, monoclonal antibodies did not make ideal therapeutics because of differences between human and mouse genetics. And this has been dealt by humanizing these murine or mouse antibodies, or by making fully human monoclonal antibodies. And it has now become standard to use monoclonal antibodies with for example, mainstay immunosuppression therapy or immunosuppressants, particularly anti-CD25 monoclonal antibody. So one of the questions in this original works was, for example, how does psychological stress associate, or how does stress associate with the above context, or in the above context? So stress is generally a medical term or medical terminology for a wide range of strong external stimuli, both physiological and or psychological, which can cause physiological responses in under the what has retrospectively been referred to as the general adaptation syndrome, first described in 1936 by Selye in the journal Nature. Selye described the general adaptation syndrome as having three main stages. So number one, alarm reaction, where the body detects the external stimuli. Two, adaptation, where the body interacts in defensive countermeasures against a stressor. And three, exhaustion, where the body begins to run out of defenses. So the question in line to this works, or this original works from 2006, was would be, or in part at least, was to understand also. It would seem acceptable that stage two, so stage two being adaptation, where the body interacts with defensive countermeasures against the stressor or a stressor. It would seem acceptable that stage two corresponds to episodes of acute allograft rejection. So studies surrounding the immune system and psychology are becoming or have become have become sort of prominent to an extent, but however, at the same time, um, a change in the amount of natural killer cells or NK cells and stress influence activity is an important defense mechanism surrounding the body. This constitutes a component of the preparation for defense against latent pathogen dissemination. The stress hormones can change immune cell activity or behavior and the activity of the entire immune system. And so, in context with the sort of backgrounds related in the original works, in this part, I'm going to highlight to highlight some aims around this works. So one of the aims was to put forward literature searches that includes organ transplantations, psychology, and particularly psychological stress, immunology, and chemokines in line to transplantation. Although this work will not and did not include formal or particular laboratory investigations, there will be sort of methodologies put forward for future or prospective research in this area. An attempt to base research on all organ transplant disciplines will be made owing to the fact that wherein irrespective of particular organ and organ and transplant specialty or discipline, generally speaking, there is a sense of commonality in context of the immune system or or in context of immunology. So an intent to base research on all organ transplant disciplines, organ transplant or transplant disciplines will be made. Linking monoclonal antibodies with the above would hopefully be of advantage. Will be of advantage. And so also to provide information or context surrounding how to achieve transplant prognosis or survival through chemokine receptor cellular adhesion molecules, and work on context in line to stress or psychological stress by propagating sort of research methodologies for prospective investigations. So in this particular section, I'm now going to highlight a little bit around the citation surrounding this works. So in around identifying particular literature, specific terminologies were listed originally, and then the listed terminologies were put into a specific database search engine. So, for example, the following terminologies form the sort of bases around this work. So there's, for example, Selye and the General Adaptation Syndrome from 1936. Chemokines, chemokine receptors, transplantation, allograft, immune system, stress, psychology, cellular adhesion molecules, leukocyte proliferation or distribution, immunosuppression therapy, monoclonal antibodies, chronic stress, and depression. In line to the sort of list of terminologies, the citation search was not necessarily in the order of words placed or listed, a combination of terminologies were used or implemented, and the majority of the database of the search was composed using the PubMed as the main database, and the citation was specifically from 1990 to 2006, wherein retrieving particular literature surrounding the works. So initially, as part of this as part of the citation and part of the citation, and in line with the sort of literature that had identified quite appropriately sort of a research questions or particular questions had formed or developed, and here I'm going to highlight those particular questions. So for example, how does psychology relate with or to transplant immunology? So for example, in context of antigen presentation, chemokine migration, and T cell activation. Another question was, how does this fit in with tolerance promotion and psychological theory? So for example, what hormones and what type of stress, and what is the link between neuroendocrine hormones, psychology, and monoclonal antibodies? And also, what is the mechanism, and in regards to in particular in regards to works by apart from Hans Selye, there was works by Redwine and team in 2003's research, which wherein a question that followed was, what is the mechanism, and in regards to Redwine and team's work Redwine's work in 2003, Redwine and team's work in 2003. What is the target of autonomic activity? And what is another question was, what is the link between psychology and autonomic reflexes as well? So I'm now going to highlight some context in regards to Hans Selye's general adaptation syndrome, wherein Hans Selye, who was a physician and an endocrinologist between 1907 and 1982, and so in context with Hans Selye's general adaptation syndrome, I thought it'd be appropriate to provide an overview of the general adaptation syndrome that was developed by Hans Selye in 1936. So in this original works from that was developed in 2006, there's a schematic that provides sort of an overview that looks at the general adaptation syndrome. So initially there's a stressor, and with the stressor there's the stressor then triggers the hypothalamus gland and the pituitary gland, and then the adrenal glands, and then from the adrenal glands there is a link to the stomach or the gut, and then the thymus lymph nodes, and also white blood cells, i.e., for example, lymphocytes or leukocytes or T helper type 1 cells or T helper type 2 cells. And in line with this, whilst that can be a stressor, or at least in the schematic. The schematic is quite the schematic is generally quite linear, but from a physiological perspective, I'm sure listeners will appreciate that whilst there can be a stressor according to a particular where a stressor can trigger a sort of a stressor can trigger a sort of a sort of an effect, so to speak. What then happens is that a number of processes can happen or take place at any one time. And what I'm trying to get, what I'm trying to sort of highlight is that whilst there can be a stressor, it's not so much that the stressor is the only aspect of the in context of physiological process that is happening at that time. So at that time, from a physiological perspective, apart from the stressor, there's also aspects of physiological processes that also take place in context of a sense of alleviation of sort of stress at the same time. However, depending on the intent of the stressor or the intensity of the stressor from a physiological standpoint, and in a sort of a linear from a linear perspective, the different aspects of physiological in works by Selye from the General Adaptation Syndrome from 1936 is generally quite linear. And so I thought as part of this I provide a little bit of a basis around Selye in context of his background as well, since I thought it'd be quite appropriate. So forms part of the sort of a story surrounding this particular audio podcast in context of the research bases as well. So Selye was born in Vienna in 1907, and as early as his second year of medical school in 1926, he began developing his sort of famous theory, his famous theory surrounding the influence of stress on people's ability to cope and adapt to the pressures of injury and disease. He discovered that patients with a variety of ailments manifested many similar symptoms, which he ultimately attributed to the body's efforts to respond to stresses of being ill. And the General Adaptation Syndrome, or abbreviated as GAS, was established more formally in 1936. So in line with this, I'm now going to look to provide an overview in context of the literature and the following the list of terminologies that were inserted into a search engine to identify particular literature surrounding the main sort of research, the main sort of research question and overall work surrounding the immune system, transplant, rejection, and psychological stress. And so to begin, studies in patients with rheumatoid arthritis first highlighted that chemokine receptors are of particular importance in the recruitment of activated memory T cells to inflammatory sites in human inflammation. It was Segreger and colleagues in 2000 that demonstrated or highlighted that chemokine cells are present in acute allograft rejection and correlate with distribution of T cells. It was Hancock and team in 2002 who highlighted and demonstrated that very chemokine receptors in context of movement exist in and around and surrounding cardiac allograft rejection. It was Cockwell and team in 2002 who demonstrated the importance or highlighted the importance in the role of chemokines and receptors in acute allograft rejection or AAR. It was Yun and team in 2004 that highlighted that chemokine receptors play or have a significant role in the development of chronic rejection and may serve as potential therapeutic targets for cardiac allograft vasculopathy. It was Jiufeng and team in 2005 that demonstrated or highlighted the unique role of chemokine molecules in the maintenance of cardiac allograft tolerance mediated by natural killer T cells in murine or mouse models. It was O'Leary in 1990 that informed that chronic stress has been associated with the suppression of immune function, and there is evidence that the immune system may not adapt over time. It was Ada and Cohen in 1993, where they informed both. When the investigators informed that both conditioning and stressful stimulation exert biological effects that can alter the development and or progression of immunological mediated pathophysiological processes. It was Dabar and team in 1995 highlighted significant and selective changes in numbers and percentages of peripheral blood leukocyte and stress, in particular psychological stress subpopulations have an effect and were identified in rat laboratory model in rat laboratory models. And then such distribution may significantly affect the ability of the immune system to respond to potential and ongoing immune challenge or immune challenges. It was Evans and team in 1995 who examined how stressful events and depression may affect parameters of cellular immunity in subjects with and without human immunodeficiency virus or HIV infection. And in HIV positive men, severe stress was significantly associated with reductions in natural killer cell populations and a subset of T cells thought to represent cytotoxic T cells, particularly the CD8 positive T cells. In HIV negative men, no clear and consistent relation between stress and immune system measures were or had been identified. The findings suggest that stress is associated with reductions in natural killer cells and cytotoxic T lymphocyte phenotypes. It was Mills and team in 1996 that examined relationships between psychological characteristics and immune responses to an acute laboratory stressor. It was Shedlowski and Schmidt in 1996 that discussed and highlighted stress and the immune system, wherein acute psychological stressors and physical activity have been shown or identified to transiently enhance immune responses. The stress effects on immunity seem to be mediated through endocrine factors, since hormones neurotransmitters and neuropeptides can interact with cellular components of the immune system. It was Lesserman and team in 1997 that investigated severe stress, depressive symptoms, and changes in lymphocyte subsets in HIV-infected men. Severe stress correlated with lower levels of natural killer cells and CD8 T lymphocytes, and findings suggest that stress and depressive symptoms may have clinical implications for the course of HIV. Psychological stress has been identified to increase circulation in concentrations surrounding epinephrine, norepinephrine, beta endorphin, adrenocorticotropic hormone or ACTH, and cortisol. There is a selective distribution of NK cells into the peripheral blood, which had been identified by investigated and identified by Pike and team in 1997. It was Gobel and Mills in 2000 that examined the effects of acute psychological stress and exhaustive physical activity on the expression and density of adhesion molecules on monocytes, granulocytes, and lymphocytes. It was Larson and team in 2001 that informed that acute stress may signal an increase in at least some aspects of the cell-mediated or Th type 1 cells, Th1 cells, cell-driven Th1-driven immune response. It was Maddock and Pariante in 2001 that informed that chronic stress appears to result in suppression of the immune response, whereas immune activation and suppression may have been associated with acute stress. Recent investigations, at least in and around when the sort of new millennium kicked in, investigations indicated that physiological levels of glucocorticoids and immunomodulatory rather than solely immunosuppressive effects exist in and around where there was a particular link with the immunological and endocrinological effects. And there is a shift. It had been identified that there was a shift of cytokine production from a primarily pro-inflammatory to an anti-inflammatory pattern. Such patterns of cytokine production can be categorized as Th type 1 or Th type 2 cells, and roughly correspond to cellular or humoral patterns of the immune responses respectively, and works by Sternberg in 2001 highlighted the links between cytokine production, the Th1 and or Th2 type processes, and how they correspond to cellular or humoral immune responses. In and around 2003, it was Redwine and colleagues that hypothesized the activation of psychological stress or stress response, and how stress responses increase autonomic activity and enhance immune function by inducing a significant increase in numbers of leukocytes at the sites of inflammation. It was Redwine and team in 2003 that also discussed and highlighted that few human investigations or studies have examined the effects of stress on leukocyte mobility, and to date, there are still no published data examining sort of the interlinks between psychological stress or stress and leukocyte chemotaxis. Chemotaxis did not correlate with catecholamine levels, suggesting that another mechanism of activation may also coexist, which increases chemotaxis after stress. It was Redwine and team in 2003 did not measure cortisol levels in their investigation or through their investigation. It was Reich and team in 2004 who discussed and highlight stress, depression, the immune system, and cancer. In general, both stresses and depression are associated with the decreased cytotoxic T cell and NK cell activities that affect processes such as the immune surveillance of tumors. It was Reich and team in 2005 in another investigation informed that at the cellular level, stressed and depressed patients had an overall leukocytosis, so an increase in particular leukocytes or white cells, and high numbers of circulating neutrophils. It was Ullig and Cullis in 2005 that informed and stated that there are plausible explanations for how psychological factors such as aspects of mood might influence immunity and immune system mediated disease. There are consistent and convincing reports of links between stress and disease onset and progression. The perfect model would be where patients stay, for example, stress-free before any form of transplantation and throughout a time awaiting a transplant. And this may well suppress those chemokine receptors that lead to acute allograft rejection episodes post-transplant. So in context of this works now, I'm now going to highlight some work surrounding proposed research methodologies, and in context surrounding this, most of the proposed research methodologies and works will relate and be in relating to information surrounding chemotaxis assays. So chemotaxis is a method for studying or investigating transport or migration towards a concentration gradient of chemoattractant for leukocytes, leukocytes, so those surrounding neutrophils, cell types surrounding neutrophils, monocytes, and lymphocytes, or other migratory cells. An upper chamber containing a suspension of cells is separated by a membrane from a lower chamber containing medium with chemoattractant. Chemotaxis of the cells from the upper chamber into a lower chamber occurs over a period over a predetermined duration of time, and the cells in the bottom chamber may be counted directly when using a homogeneous population of cells, or may be stained for defined markers when assaying a mixed population of cells and analyzed by and through flow cytometry. So in line with this, using a T cell culture system in isolation in context of laboratory medicine or laboratory research would be helpful to observe chemotaxis for number one, chemokine receptor cellular adhesion molecules and monoclonal antibodies, and to implement use of flow cytometry analysis to identify movement of particular cell types. Number 2, measuring stress and neuroendocrine levels pre and post transplant would prove admirable investigations. Number 3, the idea of monitoring stress levels in the pre-transplant duration is of obvious significance and importance. Number 4, a study or investigation with chemotaxis assays could potentially observe catecholamines with a repeated psychological stress or stress. And this would potentially allow investigators to identify how these neuroendocrine hormones affect chemokine receptor migration. Number 5, observing psychological stress in the pre-transplant stage with for example, physician-patient interaction exploration. So observing placebo variables with this would be advantageous. Number 6, a study or investigation that incorporates chemotaxis and monoclonal antibodies with neuroendocrines post-transplant would be of intrigue. Number 7, comparing some of those that have been highlighted in context of the pre-transplant phase would again observe or could observe the chemokine receptors and neuroendocrines without monoclonal antibody therapy. Examining the effects of acute psychological stress and exhaustive physical activity on chemokine receptor migration would again be of advantage. Number 9, investigations with natural killer cell activity, NKCA, and cortisol with chemokine receptors in pre and post transplant phases may also be noteworthy. Number 10, conducting investigations that relate acute chronic stress, cytokine activity, and depression may show significant correlations between the immune system and patient mental attitude. Number 11, measuring neuroendocrine function with the hypothalamic pituitary adrenal axis and system and chemokine receptor migration in pre and post transplanted recipients would also be advantage. So in line with sort of what's been highlighted thus far, this next section surrounding the immune system, transplant, rejection, and psychological stress would link into an overview, sort of highlighting further investigations and research in line with line two. Bringing in aspects surrounding the discussion and conclusions of this work. So, based on Selye's work in 1936 and the general adaptation syndrome and stage 2, where the body interacts defensive countermeasures against a stressor, it is proposed that chemokines appear to be integral players in this complex and dynamic process. And this is where areas of psychology and transplant immunology should focus or should seek to concentrate to better interlink the parasympathetic and sympathetic nervous systems. Working in these areas may allow investigators to highlight how potentially chemokine receptors and psychological stress and cellular adhesion molecules interact with each other, and this may be crucial and pertinent to understand acute allograft rejection and T-cell tolerance on post-transplantation. Using particular methodology stated as highlighted could give a better understanding between psychological stress or stress and transplant rejection, and there is an obvious link between chronic stress, depression, and weak immune systems. So, for example, chronically stressed and depressed patients, in context of what has been evidenced, is that whereas chronically stressed and depressed patients have an overall suppression surrounding the immune system. There is no definition as to how psychological stress, whether acute or chronic, relates to transplant immunobiology, and this still remains somewhat unclear. And initiating chemotaxis assays would provide a good baseline to begin work in and around linking transplant and psychology in context of laboratory research. And so what in relating this, or in regards to this, additional sort of questions also had also been documented. So, for example, why does stress often dampen the immune system? What's the purpose of it? In context of physiological advantage, what advantage does this confer on the human in context of human physiology? As a reminder of two crucial sort of previous questions that had been highlighted. Number one, what is the mechanism, and in regard to Redwin's and team's work in 2003, and what is the target of autonomic activity, and what is the link between again stress or psychological stress and autonomic reflexes? So, in line with this, as part of this particular section, I'm going to highlight the works in and around the discussion and conclusion of this surrounding this. So, to date, or sort of prospectively versus retrospectively, so to speak, professionals surrounding transplant disciplines observe chemokines surrounding or in and around immunosuppression therapy in soul organ transplant, in soul organ specialties. So, for example, a cardiologist will soul base studies or investigations surrounding the cardiovascular system, but may compare or will compare to investigations surrounding other organ specialties. Previous investigations to understand acute allograft rejection and cytokines are commendable, and investigations have proved quite reliable. It was Inston in 2002 that hypothesized that there is an alternative pathway that causes acute allograft rejection in patients following monoclonal antibody therapy. It was Cockwell and team between 2002 and 2003 that hypothesized that in human renal transplantation there are alternative pathways that promote development of a trafficking phenotype of T cells in patients that have received monoclonal antibody therapy. Incidentally, Incidentally, and in and around this, it was Cockwell and team in 2002, between 2002 and 2003, used a T-cell culture system to analyze the effects of monoclonal antibody on the expression of chemokines and other significant chemokine receptors on the surface of T cells. So the question that followed this is thus: will investigations linking the above and psychological stress or stress variable cause more complications? So in line with this, unless stress or psychological and sort of mental attitude is accounted for in sort of prospective investigations, the idea of transplant or T-cell tolerance will remain uncertain. There is potential for further investigation in this work, but would really consist of multidisciplinary research efforts to acknowledge scope. And another question in and around this discussion is: would it not seem sensible to acknowledge that psychological stress or stress will cause a more activated immune response? So it is apparent that chronic stress and depression are linked and cause suppression of the immune system. Acute psychological stress or stress could potentially cause lymphocyte proliferation and initiate chemokine receptor migration or trafficking into transplanted organs to initiate acute allograft rejection. And it would be intriguing to conduct further investigations that incorporate a particular psychological or stress cellular adhesion molecules to observe chemokine receptor migration in pre and post transplanted patients, and better define sort of physiological pathways. There may be further stress or complications in patients awaiting allografts, causing further augment in T cells, leading to chronic stress, as well as in the post-transplant phase. And another question that follows this is: should there be a better definition in studies or investigations of psychology and transplant immunobiology? And it is really worth is it really worth pursuing this line of investigation? So the answers around this is yes, but at the time it is complex to suggest what aspects of laboratory practice would be viable. And regarding the hypothesis, or the original hypothesis in this work, so it would seem sensible to state that psychologically stressed or a stressed population will have an increase in cytokine activity, and this could potentially destroy allograft in the post-transplant durations, or at least or at least potentially cause another pathway for acute allograft rejection. So patients who persevere with positive mental attitude throughout pre-transplant stage may have suppressed chemokine receptor movement, and thus allow prolonged allograft survival post-transplant with the use of current monoclonal antibodies and use of immunosuppression protocols. The above may be true, but long-term use of mainstay drugs such as cyclosporin or tacrolimus, for example, as immunosuppressive agents, can cause an increase and do cause an increase in leukocyte proliferation and simultaneously chemokine receptor migration to allografted tissue. More studies surrounding this are still pertinent. Investigations patients who have had more than, for example, 2 previous transplants are especially susceptible to chemokine receptor trafficking and acute allograft rejection. So the discussion in and around this is where I will now look to attempt to answer some of those questions in context of in context of so now I look to answer some of those listed sort of questions in the beginning of these works and in context of the literature. So in answering previous questions, for example, number one, how does psychology relate with the transplant? How does psychology relate to or with transplant immunobiology? Number two, how does this fit in with T cell with tolerance promotion and psychological theory? And number three, what is the link between neuroendocrine hormones, psychology, and monoclonal antibodies? Number four, what is the mechanism in regard to red wine and team's work in 2003? And what is in context of what is the target of autonomic activity? Number five, what is the link between psychology and autonomic reflexes? Number six, why does stress often dampen the immune response, and what is the purpose of it? And number seven, what advantages does this confer in context of human physiology and in and around between physiology. So in context of this, and in response, and according to the literature. So number one, it is anticipated that instigating some of the investigations that have been highlighted through methodology, that answers become more apparent, and the link between psychological stress or stress in transplant or acute allograft rejection is uncertain. Until methods or methodologies are initiated, the transplant promotion, i.e. what hormones and what type of stress are psychology theory are unknown. And again, more work is required, or more research is required based on the type of stress, acute and chronic, and hormones involved retrospectively. Number three, using implemented chemotaxis assays and observing chemokine receptor migration with stress cellular adhesion molecules may potentially give further knowledge between neuroendocrine hormones, psychology, and monoclonal antibodies. And so until investigations are implemented or instigated, the link between neuroendocrine, psychology, and monoclonal antibodies are unknown. Number four, until investigations are instigated or implemented, the link between mechanism and target of autonomic activity remains to be uncertain. Number five, the hypothalamic pituitary adrenal HPA axis or system may be involved in the link between psychology and autonomic reflexes. Number six, a change in the amount of glucocorticoid hormone and natural killer cells are important defense and modulatory mechanisms surrounding the body, and aligned to this, glucocorticoid hormone and natural killer cells, and in regards to mechanisms, they're involved, at least in context of the literature. It has been highlighted that they're involved to protect and constitute a component of the preparation for defense against latent pathogen infiltration, and also when, for example, where anger is evident, and the entire body responds, it instantly becomes tense, and an individual can move toward fight or flight. Being too relaxed or completely stress-free may make cells less efficient to fight off foreign constituencies. We do not. It is not known in entirety precisely which hormones are more or less secreted in a particular situation, and it would seem dependent upon circumstances. And this is why an understanding of mental attitude is also central. Number 7, in context of advances, this allows from a human physiology perspective, for the body to be equipped and prepared for an attack or an invasion, and Selye's general adaptation syndrome has generally been important because it can be looked at from different perspectives, and how it can be adapted. Also, how predetermined aspects such as genetics can cause some to live normal healthy lives, whilst others may unfortunately have potentially preconditioned abnormalities. And so there should be a link between collaborative efforts between clinical different specialties aligned to transplantation, to allow an optimal systemic approach to the many perspectives that have been highlighted, and this could lead to a better understanding of pathways to prevent acute allograft rejection. And once again, it would seem sensible that complications caused directly through immunosuppressive agents or immunosuppressive therapies could be minimized if more investigations are linked between for example, the immune system and transplant rejection and psychological stress. So now moving into in line to this, some aspects surrounding the conclusion so anger, frustration are generally have been classed as acute stress, which can cause an activated immune response, but not as the same positive stress, where positive stress can be linked to motivational stress. For example, positive stress or motivational stress causing an increase in beta endorphin, and does not, as does physical activity. Other neuroendocrines need to be also better reported. And it's still not known, for example, what other neuroendocrines or immune components are positively or negatively expressed in physical activity, or in and around acute stress in context of transplantation. Chronic stress and depression seems sort of defined, but still not sort of established in its entirety, according to transplant disciplines. Many leukocyte chemotaxis assays are required in prospective investigations to define perspectives sort of more accordingly. Based on Selye's work and stage two, a patient who, for example, accepts illness pre-transplant, this perspective will potentially the in context of hypotheses, the patient may well progress post-transplant with mainstay immunosuppression therapy and or monoclonal antibody therapy, respectively. Following acceptance, patient may have a prolonged transplant survival when one does not when it does become when a transplant, for example, does become available. More work required linking immunosuppressive agents or immunosuppressive therapy, monoclonal antibodies, and cell surface antigens for drugs and neuroendocrine systems are still required. And again, is there a link in a question that is specifically around this? Is there a link in the first place? And so, once again, the immune system may have a suppressed action may have a suppressed action post-transplant in and around leukocyte proliferation, which would normally act against a stressor, and in this context, the stressor is the organ that has been transplanted. Chemokine receptors could also potentially be suppressed. So it is worth conducting prospective investigations in a line to propose methodologies for sort of an understanding of transplantation and acute allograft rejection, and so another question that is in relating to this is there a link between stress or psychological stress and chemokine receptor migration in patients with acute allograft rejection episodes? And the answer is that it is not known definitely. The host may there may be influences surrounding acute allograft rejection in other ways, and those are still not understood, and it would be advantageous to instigate or to explore incorporating prospective investigations surrounding psychological stress or stress neuroendocrines and their hypothalamic pituitary axis, chemokines, stress, cellular adhesion molecules, immunosuppressive therapies or immunosuppressive agents, and monoclonal antibodies. Using using a multidisciplinary research approach would enable to get a better to attain a better understanding in and around transplant tolerance. So the hypothesis is that a reduction in psychological stress or stress in recipients pre-transplant versus patients who versus post versus those who are psychologically or those who are stressed improves transplant prognosis. At this time, it is complex to say whether literature review in the works supports the hypotheses, neither for or against. And at this time, it is difficult. At this time, it is difficult to suggest. It is difficult to suggest how the hypothesis could be linked to a more sort of definitive perspective. So, in line to this audio podcast, I now want to say thank you for tuning in and listening to the overview surrounding this works surrounding the immune system, transplant rejection, and psychological stress, which was based around works that was developed originally in 2006, and once again, this has been the Shientist in this audio podcast series surrounding the ZtormCrux Continuum p.2. This has been another Storm Robotics production, and thank you for tuning in.